Hello, everybody. I'll just do a quick intro while people are kind of coming in. So, as you hopefully know, this is the aspiring speakers session in preparation for Devoxx UK, which is only a few weeks away. So the pressure is mounting. So this is intended as a little online taster session to give our aspiring speakers just a quick practice, an opportunity to try out their content in front of a friendly audience, as we all are, and potentially practice things like handling questions and feedback. So if you do have any questions that come along for each of the speakers, you can ask them at the end. That would be awesome because that's also part of it as well. So we've got four awesome speakers up today. So we've got Isaac, we've got Franco, we've got Irina, and we've also got Dolapo as well. Isaac, you've kindly volunteered to go first. So when you're ready, do you want to share your screen?
Cool. Yes. Can everybody see that?
Yep, you're good to go.
Brilliant. Cool. Hello. Today I'm going to tell you a story about how I learned Python to buy a pair of shoes. So a few key takeaways that hopefully you'll learn throughout this talk. Learning is fun. Failing is all part of learning. And a great way to learn software is by building something. The shoes that we're going to try and buy today are these. These are the Yeezy 350 version 2s, commonly referred to as the Bread because they are black and red. And they were released on February 11th, 2017. So our story begins here in 2016. This is the Keaton Auditorium at the University of Nottingham. I was a first year maths student. Our lecturer came in and said, I know you're all here to learn maths, but actually all modern mathematicians must know programming. So there was a compulsory module to learn MATLAB. For what it's worth, that's now been replaced with a module learning Python, and that should tell you everything you need to know about MATLAB. Anyway, at the end of my first year, I'd really enjoyed it. I'd learned some MATLAB, we'd done some coding, etc. So then when I got to my results day and I got some quite good grades, so I was like, maybe I don't like maths, maybe I like software. How do I become a software engineer? So I Googled it, and this was the advice that was given to me very often, was basically learn by building. Start off by doing a course to kind of learn the basics of like what's a variable, an if loop, etc. But when you're ready to kind of dive in, pick something you're passionate about, pick a problem you're having, and just go and build it, and you're going to learn so much on the way. So that's what I did. I wanted to buy this pair of shoes, so I tried to write some software to do that. So where do we start? Well, obviously at the beginning, I didn't know anything about computers or the internet or anything like that. So I thought at the lowest level, how do I buy a pair of shoes? And the way I do that is I move my keyboard and mouse to interact with the website, and some shoes turn up at my door. So that's where I started. There's this module called PyAuto GUI. This allows you to automate your keyboard and mouse movements. There are a couple of problems with this though. First of all, to click on things, you have to put an XY coordinate in that you'll see there at the bottom. This means that if anything moved around on the page, this would break the script. That's not good. Also, this module couldn't see the screen or the browser, so that meant we had to use these sleeps and just kind of like hope for the best. So we'd sleep for 5 seconds, maybe the page would load in that time. Now, this was a problem because everyone was trying to buy these pair of shoes. So the slower we were, the less likely we were to buy these shoes. So we wanted to be as fast as possible. So obviously we're software engineers, we like to iterate. The second thing I did was automate the browser. I used Selenium for this. I know that's not the tool these days, but you have to remember this was back in the olden days. And this solved a couple of problems. The way this works is it can actually see and interact with the underlying HTML. So that means we can do things instead of like looking for XY coordinates, we can say, go and find a button with the view product one label and click it. It also allows us to see when things are loaded. So we can use this wait until presence of element located, which means we will no longer be waiting unnecessarily. And like I said, faster is better. But what was the next step after this? Well, what I learned about was actually websites are just ways of building API requests, and actually everything that happens is on the server. So why would it be quicker to talk to the API directly? Well, when we load the website, we have the request that we're actually sending. We then have a bunch of images. This is the modern day, so there's trackers for everything. Everything you do is tracked, so you have to load those in. There's also even 50 kilobytes of fonts being loaded each time. Whereas if we could talk to the API directly, that's a lot less data, which means we're going to be running a lot faster, which is good. So how do we do this in Python? There's this requests library. So after some exploring around, I had some poking around and I found out that the process was actually two requests. First of all, it was a put request to this cart API. You send it the product that you want, the quantity, and the size. This then returns a JSON response. In there is a unique checkout URL for your cart. You send the post request to the server, and then ideally you buy the shoes. Now, this was great. This was, in theory, would work. One issue we had is it was synchronous. Now, this isn't inherently an issue, but I was really excited that I got some stuff working and I was at university. So I went and told all my housemates. I was like, do you know those shoes we want to buy? Well, I've written this piece of software that's going to buy them. And they all went, well, can we use it? Like, I'd love to buy a pair of shoes. Now, the thing about my housemates is they're not technical at all. Some of them could barely even use a calculator. I wasn't going to try and explain how to load up a Python environment, tweak the code, etc. So I said I'd run it for them. This is where it being synchronous then became an issue because my sixth housemate would have to wait for the first five housemates to check out, and that put them at an unfair disadvantage. So we had to move asynchronously. We swapped out the request library for the HTTPX library. We run our script in this main function, which still had this add to cart and checkout function, but we wrapped that all in a run function, which would generate 6 tasks, is what we call them in Python. And as soon as the shoes were released, it would send out all 6 scripts at the same time, run them in parallel, and then ideally everyone has a fair chance at buying these pairs of shoes. So, did it work? Obviously, we've iterated over, we've solved lots of problems along the way. When it came down to it, the golden time, did it actually work? Well, no, obviously not. The Yeezy developers are far more competent people than a first year math student who's just learned what an API is. So, that didn't work. But some of the more keen-eyed among you might be saying, but Isaac, those Yeezys that we talked about are on top of your books right now. And I say, oh, you're right. So how did we get there? Well, obviously, software developers, we love automating everything, but sometimes you just have to go and do it the old-fashioned way. So I woke up at 5 a.m. I stood outside a shoe shop for an hour in the freezing cold with one of my housemates. The other ones didn't fancy it at 5 a.m., funnily enough. And I managed to buy these pair of shoes. And this is a photo of me on the bus back home. So hopefully you've learned along the way. Learning can be fun. Failing is all part of learning. And a really great way to learn is by building something you're passionate about. Thank you very much for listening.
That was really good, Isaac. Well done.
Thank you.
Silly question. Are you going to wear the shoes to Devoxx so that you can point out the shoes?
Yes.
That's a good idea.
The only thing on my list to do that day is like shoes in big bold letters. Make sure you wear the right pair of shoes.
Absolutely. Has anyone got any questions not related to shoes that they would like to ask Isaac? On you go, Franco.
Yeah, nice presentation. One question. So what happened after? Where did it take you? Like you learned the basics from it, is what I got from it. What happened after?
I got a job writing software for a living. So yeah, I'm now a technical lead. So I've worked my way up. But yes, that was the basis of half of my interviews have been like, oh, tell me more about that shoes that you basically bought, because I guess it shows initiative and passion, all that. So it's definitely helped me get to where I am. And yeah, of course, I learned so much along the way.
Cool. Any other questions before we move on? No. Okay, cool. Right.
Thank you.
Thank you, Isaac. Delapo, you ready to go?
Yeah. Hello, everyone. I am Dolapo. I am a cloud architect. and I support community operations at Architecture. I also founded Unira Studio, and today I'll be talking about cloud, code, and curiosity. I would love to ask everyone on the call a simple question, and that is what I have on the screen. When did you last do something you weren't sure would work? It might be something you genuinely didn't know if you'd be enough for it. Sit with that for a second, we'll come back to it. I didn't come from a traditional tech background. I came from a different field. And at some point in my career, I looked at where everything was heading, cloud, quantum computing, AI, the whole shift in how systems are being built. And I thought it is either I move towards this and become part of the solution, or I watch it happen without me. So I asked myself, what is the worst that can happen if I fail? But then, what if I fly? That changed everything, and that's what I want to talk about today. Now I've gotten into the industry, and just like many of us, that's where we started, got into the industry, spend years getting sharp. We learn the tools, the patterns, the stacks, and then again, we hit a ceiling. You can be genuinely technically excellent and still feel completely stuck. And that is why we have to be intentionally curious. And this gap boils down to three things: experimentation, systems thinking, and communication. On experimentation, when I moved into cloud architecture, I had no guarantee that I would scale into it. But here's what I've come to realize: the experiment is the actual point. I started out with the curiosity and the intention to grow in this field. I honed my learning. I started a blog on cloud code and curiosity. Yeah, same as my talk title. So I shared the journey publicly, and that consistency got me to where I am today and also opened doors for me. It was an experiment that compounded. And what I've come to realize over time is that you stop experimenting because you are good at what you do and it works. So you optimize for what already works and quietly stop growing. The career decision that you've been putting off because you are not sure you are ready, that's the actual experiment. And not making a decision is still a decision. So why not make it count? And it is not every experiment that works, and that is totally fine. A failed experiment teaches you something, and it is one of the most valuable data points that you can collect in your career. The career decisions or the decisions that you regret are actually the experiments that you haven't run. So moving on to systems thinking, you've run the experiment, you are growing, and then something shifts. So the question stop being about your code and start becoming, what does this decision cost someone else 6 months from now, 1 year from now, at 2 a.m. on the bus or anywhere? You start thinking in systems. Do we have anyone in cloud architecture in the room? Okay, then you know that if you have anyone in cloud architecture in the room, we know that cloud is not a technology, it is systems at scale. Your decisions ripple into other teams and into production, into how fast the organization can move. And this is system thinking and it grows in levels. You start by writing code that works. That is the first level. Then you start seeing how these components interact, why the trade-off exists, the systems. Then you realize that the humans and teams like this interest are part of like the system to socio-technical, that is the third stage, and the highest level, which is the strategy stage. You are no longer just building the system, you're also shaping it, shaping what gets built and why, and you're already part of the system. And once you can see this, then you hit the next role. Can you bring others with you? Because that's where communication actually comes in. So seeing the system isn't enough. You have to be able to say it to your teams, to the stakeholders, and room full of people that don't just write code, but are the one that shapes how decision get built. This skill is what makes everything else compound, and it is communication. So first, you have to be able to listen before you propose. Second, disagree to agree to disagree, and disagree without making it becoming personal. Third, explain the system to people. If you can't write it clearly, then you don't fully understand it yet. Fourth, get people moving together. It is not about the clarity of explanation, but what happens after it, whether the room left aligned. So in my previous experience, that actually became an asset for me, and it turns out I wasn't just curious about cloud. I was also curious about what I could contribute, and it turned out that the communication muscle that I built before tech was part of the answer. So if you've written publicly, spoken at a meetup, managed client or a difficult organization, that is your superpower, and you shouldn't underestimate it. So yeah, back to the question that I asked initially. When did you last do something you weren't sure would work? I still don't know how far I'll go with cloud architecture, and I don't know where it ends, but I stopped waiting to find out. And standing here today is one of my experiments. Here's what I know. Curiosity without intention takes you nowhere. And the people that continue to grow and shape what gets built in the industry for the future are the ones that turn curiosity into deliberate experiments. They learn to see systems and they find the words to bring others with them. So keep the curiosity and add the intention. And whatever that experiment is that you've been putting off, the role, the technology, the conversation that you haven't had yet, go run it. So, in summary, curiosity is how you start, but the intention is how you grow. And the things you thought were unrelated to your career are often the most valuable parts. Yeah. If you'd like to stay connected with me, here are my handles. And thank you. I hope you enjoy my talk.
Thank you so much. That was really good. Right. Does anyone have any questions for Dolapo at all?
Can you give us an example of where you had to experiment or be curious on your own path, and where did it lead you?
You can experiment on virtually everything. But for me, my experimentation was about like having that uncertain moment about cloud computing. I didn't know where it was going to lead me or if I was going to succeed in it. So I started out learning more about cloud computing, starting with the AWS Restart program. And from there, I started to document my learning, everything that I learned. I started documenting it on my blog and I shared this widely. So it was through this that I got noticed in the industry and I got a mentor. And from that mentorship, I got a role, and it has been through one stage to another, and it is even through that curiosity and that role that led me to like getting here today to be able to speak, because it is my mentor that actually inspired me to apply for speaking at Devoxx, and I think it's all part of like the experimentation.
Thank you. Great answer.
Thank you, Shanna. It's good to have people asking questions. That really helps as well. Cool. Right. Okay. Franco, you're up next. Are you ready?
Yeah.
Cool.
I'll share my screen. Cool. All right. Hi, everyone. I am mouse is in the wrong place. Apologies. I am Franco Cassar Manghi, originally from Malta, but based in London. I speak a myriad of languages. My background is in software architecture and software development, both in computer science and artificial intelligence, but I work mostly in the telecoms area. And today I'm a group engineering lead of Devoxx. So a bit about me, a bit on the side now. Why are we here today? And what I want to talk about today is my experience in the last few years of managing always this tough balance between long-term capabilities that we want, both from a technical roadmap and business features that we want to build, but also getting value out there as quickly as possible and not having that value compromise your long-term goals. So we all are familiar with a classical legacy scenario in most corporate environments. So you start with some typical replication in the middle, you add a feature, you add a database, you add some more feature, another database somewhere somehow sneaks in the same application, and then you start to see now crisscrossing between them, some loops that shouldn't be there. Then you have external code that tries to add functionality without touching the core of it. And we've all seen bash scripts and files that go out and then sent over to somebody. And then we go into a world of building some new services with all the hype of, let's say, microservices, but still end up somewhat integrating with the old one. and trying to mix and match the old with the new, making everything look new. So we end up going in this world of new services, but yet backfilling into and proxying into old legacy. We are always afraid of building new features because we're afraid from breaking this delicate balance. And a small idea effectively becomes a big effort. So we all know basically why this happens. So we go into quick hacks, short-term wins, commercial pressure that forces us to go down this path, and again the risk of changing complex applications. So designing a new end-to-end architecture that replaces all the old functionality is a huge waterfall project, and that would take years and returns very little commercial value. And designing individual external satellite services, as we've been seeing here, will just add more chaos to this mess. So how can we fix this? Let's focus on a long-term vision with an incremental plan within it, performing frequent cycles that returns value. It's kind of a mouthful. We'll talk about this shortly. And the other point is API and event contracts that are forward compatible. This means we can keep extending as we evolve. Now, I like to make this analogy with a cake slice. So we've got the cake, we've got a slice there. So we have a good idea of the cake that we would like to have. And then ask yourself, what is the thinnest slice that you can cut where you still taste all the layers of this cake? Cut it, and then get enough ingredients to bake that slice alone. Each slice should give us an end-to-end version of a working solution. Sure, we're missing the whole cake, but we are getting a good idea of what that cake tastes like, what it does top to bottom. It's important that it's not of one component, but basically the slice is effectively part of the full solution end-to-end. A solution that you know how to keep evolving one slice at a time, which is why I said you need to know what your overall cake looks like, even though we have not baked it all. But also each slice returns value because it's top to bottom. We can understand what we like, what we don't like about it. We start getting feedback early before we've done that whole cake. So things like insights, metrics, steps, revenue feedback, and so on to help us there. Then I touched a little bit about forward compatibility and API design and contracts. So if you look at this example here, it's an order API. And on the left-hand side, we looked at the product object in this order item. Sorry, in this order, it has a price. However, this is already problematic. We know we want to sell multiple products a few months down the road. But for some reason, we built our MVP not as an array. That not being an array is problematic because now suddenly, if we want to iterate in our next slices, we are going to actually have to redo some work, not just on our backend services, but our consumers as well. There's no thought on the price evolving. So even an MVP, okay, the price is 2,300 pennies, for example. But actually, we already know we need to take into consideration things like tax or discounts later on. So that is not a forward compatible structure. And similarly, something like the owner information, again, same principle. We don't want to over-engineer, but we also need to keep in mind where we're heading, not to put ourselves into a corner. So in this example here, we can see how this could actually evolve. So the one on the left is your MVP one, where it's basically just an array with the same data that we had in our first version. So we did not really add any more efforts to it. The right-hand side is where it could potentially go. And we start to see that we introduce discounts, RRPs, more information to the owner. It doesn't mean that our cake had the right side on day one. It had the left side, but it left space for the right side to happen. And the other point that also comes out very clearly here is your common language part. So I labeled a little bit these objects with e-commerce money or order owner. Look at e-commerce money. Whether it's a final, discount, RRP, is the same object. That means anyone that's interested in a final price or interested in a discount or interested in an RRP, they know how to read any one of those because it's the same language. They both contain a value, they both contain text information, and so on. So I want to bring some examples of how we achieved this, and we did a concept last year when we introduced airtime travel add-ons in DivDev. So we proceeded with the slice concept, and each horizontal row is basically an end-to-end slice with some audience for it. So almost immediately we added a feature flag, we configured a primitive add-on on the network, put it in a catalog, let's just sell it to staff users. It was limited audience, of course, we were missing some guardrails, missing some eligibility controls and so on, and kept adding to it. So now we presented things, we integrated native checkout, we showed what the user has active right now, and this now and then allows us to expand it not just to staff, but also to some test audience that we have externally as well. And it kept going on for the soft launch and commercial launch. This whole initiative basically gave us 2 timelines. In around 3 weeks, it was enough time to get external user feedback. And in just 7 weeks, we went to full launch and launched this product entirely publicly, end-to-end from the mobile app to our actual users, the network impact, and so on. So now we're taking this further and better. So we're again looking in the airtime space, but we're trying to modernize the e-commerce stack. I started earlier talking about that legacy architecture and so on. So now we're trying to start fresh. How would an e-commerce work? And then we take the same slices concept. So each slice has an audience that consumes it in production. Slices 1 to 4, we're actually in the middle of it, just finished slices 1 to 4 right now. So we've got functional end-to-end checkouts and returns. And then in 5 weeks, we managed to achieve this. And then now we need to start looking at things like eligibility, promotions, and legal constraints. But then each of these activities are end-to-end. As something is in place, we can still go through a full journey, experience the whole feedback end-to-end. And finally, slices 9 and above, it's where we keep iterating with a full launch and so on. So closing tips, end-to-end slices, but always remember the full take. Forward compatible API contracts within reason. You can't over-engineer it, but don't put yourself into a corner unnecessarily. And common shared language model in APIs. Do not expose internals or vendor specificity. So these are my 3 closing tips for you all. Any questions?
Thanks so much, Franco. That was really interesting. Does anyone have a question for Franco? If not, I can ask one.
I've got one too.
You go, Shanna, you get priority for questions.
How do I know when I've got a good slice? Not too big, not too small, just the right size.
So try to ask yourself, give a reasonable time that is acceptable to you. For some parts of the project might be a week, or it might be 2 or 3 weeks. It might be change a little bit over time. And ask yourself, in that small time, what can you do that works end-to-end? And what works end-to-end can be done in a way that you increment on it. So this is where you need to be a bit careful between an MVP that proves a point and an MVP that can evolve. Some MVPs are proving a point, but you have to throw it away. That's not really sustainable long-term, and you will end up wasting more time. So these are the questions, and use that to guide you on what's important to build right now.
Amazing. Thank you. I love the cake analogy.
Thank you.
Well, we are doing well for time, so actually, Franco, I'm going to ask you another question. So you talked about the introduction of feature flags and then having each of the incremental slices. How do you manage feature flags to make sure that they don't end up becoming like something that clogs your code? Because that can be an anti-pattern that can, to your original point, make it harder to actually end up adding features in the future. So do you have any strategies for that?
It's a very good point, and I guess it's partly discipline as well, realistically, because no automated process will just clean it for you. There are some things you could put in around the metric side. So usually feature flags are tied to experiments which we are running and measuring metrics on. One of the metrics would be the age of that experiment and the flag, and you start to have those metrics impact your decision making as well. But ultimately, you need a process to go in and clean up at one point, make a decision, keep it, get rid of it.
Yeah, no, that makes sense. I like the metrics point though. That's really interesting. Thank you very much. Cool. Franco, thank you so much.
Thank you.
Right. Last but not least, Irina, are you ready to go?
Yeah, I love anxiety build up. So I want to apologize because my slides at this point are very raw. They're going to change,
Yes.
but right now they're pretty raw. So
Don't worry, that's why we do these as a practice run. You should see some of my slides in the first talks, the first version.
Okay, let me share. Let me. Yeah. Okay, so my name is Irina Ponomarenko. I am a career changer, and I'm a junior software engineer at a company called PhysicsX. And I want to start with a confession. Because I'm a career changer, when I first started my job in tech, I understood maybe like 10% of what was going on. Meetings, acronyms, systems, tools, more acronyms. It just flew over my head. And my main strategy was stay quiet and hope that no one notices. Because I genuinely thought, I'm new, I don't know anything. What can I say? But let me start from the very beginning. My onboarding was chaotic. The person who was supposed to guide me disappeared for 3 days, and I was left alone with piles of unsorted documentation, and even the basic things like setting up my environment just didn't work. And I thought, this is so hard because I am inexperienced. But over the next few months, I talked to enough new starters to realize that everyone struggled, even experienced hires. And that was my first shift from I am the problem to, oh, maybe the problem is actually in the system. So I wrote my own onboarding guide. What I did step by step, painfully detailed. How to set things up, where to find things, who to ask, what actually works and not what docs say work. So today it's one of the most used onboarding tools in the company. And it's so only because I was new enough to notice what didn't make sense. And this is the first idea I want to leave with you. Fresh eyes are a diagnostic tool. But noticing problems is one thing, right? Oh, I realize I'm not moving my slides. Sorry. So noticing problems is one thing, and saying something about problems is a whole different game, right? Speaking up feels very risky. And well, let's do a show of hands. Whoever sat in the meeting thinking, should I say something? What if I look stupid? Yeah, cool. That's what I'm talking about. I'm the same. And the honest answer is yes, that might happen. I might look stupid. But I made a deal with myself. I call it 3 seconds of crazy, stupid courage. Don't overthink, don't analyze, don't prophesize what might happen. Just say the thing. It takes 3 seconds and then it's over. It's done. And sometimes it works really well. Like when I noticed that our linting process was inconsistent, what passed locally just wouldn't pass in CI. And I brought it up, I fixed it, and suddenly everyone in the team was thanking me because it removed daily frustration. But don't let me fool you. Sometimes it doesn't work. Once I tried to change how my team wrote tickets. Paula in the audience would know everything about it. The way they write it is they just write the name. The way they write it is just the name. So there is no description, there is no links, no logs, nothing. And it used to take me half of the day to gain context on what needs to be done and where. So I made a lot of fuss about it. I made a whole presentation, beautiful slides, much better than these ones, I promise. Definitions, comparisons, best practices, and it just didn't land because I was asking for a big behavioral change from them that mostly solved my problem. But even then, something shifted. We introduced refinement session as the result, and everyone who needed more clarity could get it there. So even if what you're doing is wrong, sometimes it can move things forward. That brings me to something that I learned about more senior teams. They're incredibly good at focusing on big and important problems. They are juggling architectural decisions like it's nothing. And because they're so used to implement something new, they have very high tolerance for friction. Outdated docs, broken commands, clunky workflows, they just don't notice things that technically work, but make everyday life harder. And juniors, we feel that friction immediately. We don't know what's normal, so we can question everything. And this is a practical way to use that. Think about your job as a product and yourself as a user. So your everyday job is your user experience. Where is the friction? What is confusing? What is slow? What doesn't work the way you expect? And then ask, what is one small thing that I can do to make it 1% better? Not perfect, not revolutionary, no, just slightly less annoying. Because small improvements compound. Before tech, I used to work as a pastry chef. And one of the most impactful things I ever did there was introducing a weekly stock count. Nothing fancy, just a printed spreadsheet. But in 3 months, we reduced our waste by 40%. So it's same principle everywhere. Small change, real impact. So if you're sitting in the meeting thinking, this looks broken, but am I senior enough to say anything? Try this. Notice the friction. Fix something small about it. And when in doubt, take 3 seconds of crazy, stupid courage. Because you don't need authority to improve a system. You just need to care enough to notice what needs to be improved. Thank you.
Thank you so much, Irina. I'm going to take that away. Crazy, stupid courage. I like it. Does anyone have a question for Irina?
I've got a question. When you've raised potential points that could be fixed or potential improvements, have you ever received any resistance?
Yes, I think I gave an example when it didn't work, when I asked my team for a better way of writing tickets, for example, and there was a huge resistance because it took time of everyone, like everyone needed to spend more time for me to understand something better, right? This is a huge huge ask for someone. So yes, I faced quite a lot of resistance, but it also started the talk about that the current system doesn't really work for everyone. So even if the solution that I proposed, and my solution was the definition of done and definition of ready, even though that wasn't accepted, they still realized that the current system doesn't work and something needs to be changed. So they find a different solution to accommodate more junior team members.
Yeah, so if I understand correctly, sometimes fixing the problem isn't the only positive outcome. It's just highlighting that there is an issue.
Yes, yes. Even if it didn't land, even if something went wrong, even if you did look stupid, it still can have the positive outcome.
Fantastic, thank you.
Cool. Are there any final questions for Irina or any of our speakers who've gone today? Nope. That's cool. So again, a couple of little announcements and then we can head off early. So again, thank you so much to our awesome aspiring speakers. I hope you found the practice run useful and the opportunity to have questions and things. I have been making some little notes in the background, so if you want my feedback, let me know. I never push or force it, so if you want it, that's fine. I'd also encourage you to sync up with your mentors as well. We will be sharing the recording out if you want to watch yourself back. I know it feels super cringy, but it was something that did help me as well. So I'll share the link if you want to do that as well. Um, for everybody else, thank you for coming along and supporting. Obviously, it's really important to have an audience as well. If you would like to give a lightning talk, I'm always looking for speakers. So I've pinged in the chat the link, but you can also reach out to me if you've got an idea and you're not sure it'll be interesting. Please come and ask. I'm happy to help with that. Our next session is going to be in May, after Devoxx, of course, on the 26th, which is a session that Anthony's scheduling. I'll be pushing that one out on Luma and on Eventbrite soon, so you'll get to see, but it's more of a panel-like session. And if anybody has anything else they'd like to cover, not just in terms of lightning talks, if you want to do something longer, if there's a topic that you're really struggling with speaking or career development and you'd like to hear people's experience or advice on it, please ping myself and Anthony. We're always looking for ideas of what kind of things to run. And with that, I hope this has been a good lunch hour and you've enjoyed it. If anyone has anything else, you know where to find me. And I'll let you all get on with your day. Thanks so much, everybody.